of magnitude is totally different than sig fig. If sig fig talks about the reliable digit, you keep measuring until you find the last reliable digit, which is the first uncertain number, right? The order of magnitude is 180-degree different than sig fig. The order of magnitude is just guessing. Let's start with guessing. Moon, and the distance between Earth to Moon is 384,000 kilometers. Okay, so if I ask you how many dollar bill do you need to make a staircase between Earth to Moon? Okay, if you take a dollar bill, this is a dollar bill. If I ask you how many dollar bill do you need to make a staircase from Earth to the Moon, you probably have to use order of magnitude and not sig fig. Since we are not using sig fig, and since I don't have so many dollar bill, I'm gonna use the A4 paper. Why is that? Do I care about thickness of A4 paper and dollar bill? No, I don't. Why? Because it's not significant figures, it's order of magnitude. It's kind of a guessing game. So I'm gonna count how many papers I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm not gonna even bother taking the rulers. I'm gonna just eyeball it. This is 1 millimeter. $10 bill is 1 millimeter. 10 bills is 1 millimeter. Okay, so then millimeter has to be cancelled. Then the meter is down. However, I need kilometer because I give you information to create a staircase between Earth to Moon by using kilometer. So the kilometer, meter has to be cancelled, kilometer has to survive. So 1 meter is 1000 millimeter, and of course 1 kilometer is 1000 meter. What you can do, cancel millimeter, meter, what survive? Bills over kilometer. So you have a bills over kilometer. How much? 1 times 10 raised to 1, 2, 3, 4, 5, 6, 7. Okay, you have 10 raised to 7 bills needed. All right, 10 million bills to create a staircase between Earth to Moon? Oh, of course not. To make the staircase 1 kilometer above the Earth. So to create the staircase from Earth to Moon, what do you have to do? You have to multiply this guy with the distance between Earth to Moon. 384. Well, let's round it because this is all guessing, right? This is approximately 400,000 kilometers. So let's write 400,000. Do we care about the precision? Oh no, just want to guess. Kilometer cancel. How many dollar bill do you need? 4 times 10 raised to 7 plus 1, 2, 3, 4, 5. So 4 times 10 raised to 12 bills. That means you need $4 trillion bills to make a staircase between Earth to the Moon. Practical? No. But can order of magnitude help you to do something? To thinking, to start thinking, to making a staircase between Earth to Moon. Yeah, of course. That's how human start thinking. It's a very powerful tool. Today's thinking is to tomorrow's reality. So order of magnitude is something that you use in your thinking. Thinking doesn't cost money. You don't have to spend money to think. And that's what you use to start thinking. And then you take it to the lab, and then of course you do it by precision. Okay, so let's use the math. If I have a number line, if I have a 0, 1, 2, -1, -2, the next, what is the 2 consecutive number if the first number is 0, 1? But if I have 1, 10, 100, 1000, 10,000, 0.1, 0.01, 0.001, 0.0001. Of course, I can write this one 1 times 10 raised to 0, 1 times 10 raised to 1, 1 times 10 raised to 2, 1 times 10 raised to 3, 1 times 10 raised to 4, 1 times 10 raised to negative 1, 1 times 10 raised to negative 2, 1 times 10 raised to negative 3, 1 times 10 raised to negative 4, and so on. Now, if I give you 4 numbers, let's say this is the measurement. You have 2000, you have 4000, you have 8000, you have 0.0002, you have 0.0009. Okay, scientific notation. You have, let's find the sig fig here. You have 4 sig fig, 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 you have 4, you have 1 sig fig, you have 1 sig fig. Okay. All right. So scientific notation. You have 2 times 10 raised to 3. You have 4 times 10 raised to 3. You have 8 times 10 raised to 3. You have 2 times 10 raised to negative 4. You have 9 times 10 raised to negative 4. We're going to try to find the order of magnitude. Order of magnitude. To find the order of magnitude, we have to use this. You see, arithmetic mean is a plus b divided by 2. Geometric mean is square root of ab. We're going to use the geometric mean because 2 consecutive number is the difference of factor of 10. What does that mean? If the first number is 0, second number is 1. If the first number is 1, second number is 10. How can you abstract it? If I say 1 plus 1 is 2, then how can you abstract this idea? N plus n is 2n. If I say 2 times 2 is 4, how can you abstract it? You say n times n is n squared. Okay, so we're going to abstract this. By the way, before we do abstract this, we're going to write the formula for this one. N is the scientific notation. A times 10 raised to small n. And a is less than 10 and greater than or equal to 1. And n is a whole number, integer. So now, if first number is 10 raised to n, is the second number 10 raised to n? No, second number is 10 raised to n plus 1. So n is, first number is 10 raised to n, second number is 10 raised to n plus 1. So n is 10 raised to n plus 1. So n is 10 raised to 2n plus 1. So I'm going to put 2 over here. So I'm going to write 2, 10, 2n plus 1 divided by 2. And then I'm going to write n is equal to 10, 2n divided by 2 plus 1 divided by 2. And then I'm going to write n is equal to 10 raised to n plus 10 raised to half. So n is 10 raised to n plus 3.16. So now here's the deal. If a is less than 3.16, then you leave this alone. Then 10 raised to n plus 0. If a is greater than 3.16, then you write 10 raised to n plus 1. Okay, let's do that. A is less than what? A is less than 3.16, so that n plus 0. So 3 plus 0. So this is 3. A is greater than 3.16. So then 10n plus 1. So 10, 3 plus 1, which is 4. So this is 4. A is, oh, we didn't do this one. Oh, we did this one. Okay, so let's fix it. So this is 3. This is 4. We didn't do this one. Let's do this one. A is greater than 3.16. So then 3 plus 1, which is 4. A is less than 3.16. So negative 4 plus 0. So this is negative 4. This is negative 4. So A is greater than 3.16. What is that? Yeah. Then negative 4 plus 1. So then this is negative 3. Now let's see whether they are right by using our common sense. True number 2000 is close to true number 10,000 or 1,000. However, 2000 is close to 1,000, and that is what I'm going to circle. And the check. Okay, let's do the next one. 4,000. 4,000 is close to, of course, true number 1,000 or 10,000. How the logarithm affect it? Can you come over here and explain that? Come.
Logarithmic scale. See, the graph of a logarithm looks like this, which means that as x goes up, the rate of it going up goes down. So it starts getting very slow over time. And what that means is that while the difference between 1,000 and 4,000 is 3k, and the difference between 4 and 10 is 6k, in normal math, on a logarithmic scale, because 10,000 is so much bigger and thus so much farther up the curve, the difference between it and 4,000, it's much lower than the difference between, well, not much lower, almost the same, but still smaller than the difference between 4,000 and 1,000. And you can actually observe this by realizing that the logarithm of 1,000 with respect to 10 is just going to be 3, this is going to be 4, and then 10 to the 3.5 we know is going to be 10 to the 3, 1,000, times 10 to the 0.5, which is about 3.7, which means that anything above 3,700 approximately is going to have a logarithm closer to 10,000 than 1,000.
You're going to round it to whole number, which is 4. Okay, so that agrees with our answer. Okay, 8,000. 8,000 is close to 10,000 or 1,000? 8,000 is close to 10,000. So check. 0.0002 is close to this or that. 0.0002 is close to this, and our answer check. This or close to that. Of course, it's close to this one. And that's what our answer gives us. Okay, so answer does make sense. However, you can verify all of those by using log. As Shubhanda explained, 2000. You're going to round it to whole number, which is 3. Log 4,000. You're going to round it to whole number, which is 4. Log 8,000. Round it to whole number, which is 4. log minus no 0.0002, this is minus 4. You're going to round it to a whole number. Finally, log 0.0009, you're going to round it to whole number, of course, -3.